Okay guys, welcome once again to another video. In this video we want to continue where we stopped, and I will highly advise, if you have not been able to watch the first video that happened to see where I teach the theory of computation, that happened to be the notation mathematical aspects, then do well to watch that video because it's going to help you. If you don't watch that video, what we are doing here, you will not really get it, because we'll be doing some application. So this finite state of machine, or FSM, it is more like application of all what we have learned in the first video. So I highly recommend you to watch that video. Thank you very much. So on this one now, we want to do finite automata. In finite automata, we have this diagram on the board, and this says the finite automata with output and finite automata without output. Well, I'm not going to dwell much on this. I'm not even going to touch this. As far as this course is concerned, we are going to talk on this. So this is without what? Without output. Okay, so let us see how we want to at the end of the day want to dive into this the more. But I just want to show you the diagram. This is more like an architecture of finite automata. So more we go deeper into this and explore on that. So first we have DFA. DFA stands for Deterministic Final Automata. NFA stands for Non-Deterministic Final Automata. And the last one there is what we call epsilon. And this is the reason why I said go and watch the first video. Now, those of you that haven't watched the first video, this thing you see here, you'll be confused. The epsilon simply means empty. Epsilon means empty. This one is a notation. So the epsilon means empty. That is empty NFA. That's what it means. So that's for that. So I'm going to rub this off now. So let's move on where we stopped. So we want to go deep into deterministic finite automata. Now, what I mean deterministic finite automata, this simply means that this is an automata that the next stage, the next phase, or the next stage is determined by a particular input. Let's say, for an example now, we have the first input, right? First input entering the first state. Now, whatever happens that makes the first input move from this first state to another state, we can only determine that by the input that comes in. That's what it means by deterministic finite automata. That means it is the input that decides what happens if we have the next or we don't have the next stage. So I think that's very clear. So, but let me just read up from what I have here. I say a deterministic finite automata, which is DFA in short, is a specific type of finite state machine, FSM, where each transition from one state to another is uniquely determined by the input symbol. In other words, given the current state and an input symbol, there is only one possible next state. DFA are characterized by their simplicity and determine, making them suitable for tasks such as pattern recognition, lexical analysis in compilers, and network protocol analysis. So now let's say, for an example, in practical terms, let's think of DFA like a traffic light system. In practical terms now, I'm just trying to make this basic this foundational explanation just for us to understand the reason, essence why we are doing this. Shouldn't be like we are just going straight to work and somebody is not really getting what exactly is the reason why all this thing is coming up. So let's talk about, in practical time, think of DFA like a traffic light system. There are specific states. So we have the red light, we have the green light, and we have the what? The yellow light. Now, the transition from one state to another is determined by certain condition, which is, example, pressing a button or timer reaching 0. This simply means that is the reason why in traffic lights, what makes a particular state, the light, to change from one color to another is determined either by one of these. It is either somebody is standing somewhere pressing a button that says, okay, after if I press this button, if I press a particular button, this will change from yellow to what? To green. If I press a particular button, this will change from red to another color or yellow to another color. Or it is either somebody is pressing a button there behind um, the scene, or there is a timer reaching 0. That simply means that there is a particular time that has been set. This is like more of like a programming work, that once that time counts from 10 seconds, 10 seconds, 10 seconds, 9 seconds, 8 seconds, 7, 6, and down towards 0. What happens is that once it gets to 0, the color changes from one particular color to another type of color. So you could see that these two things could be in terms of traffic light. These two things are what could determine what could determine the next light that will come up, and in other words, is what could determine the next state of the words of DFA. Now that's for that. Another one there is it's deterministic. It's deterministic because for each state, red light, there is only one possible next state based on the input when the timer runs out or when when a button is pressed. So this deterministic behavior makes DFA useful for tasks where precise, predictable behavior is needed, like parsing and analyzing strings in in computer science. So I believe that is very clear. We've been able to establish basic knowledge on that. So let us see how we want to go deep into this deterministic matter. So DFA. Now, if we want to do DFA, there are certain things we just need to understand also. The first one we started with. DFA stands for Deterministic Finite Automata. Well accepted. Another thing that it is the simplest model of what? Of computation. Why did I say it's the simplest? Because it only asks whether or not, when we are trying to make a decision of, okay, we want to move to a particular state, the only possible state that is available at that moment is just one state, which is the next one. But in non-deterministic finite automata, it is not like that. We could have multiple states. So a particular state can lead us to different states entirely. But when we talk about DFA, the only possible state we have, which is the next state, is just one. And the input determines whether we are moving down there, moving to the next state, or we remain wherever the current state where we find ourselves. So this next one here is so this is the reason why it is the simplest model of what computation. The next one, it has a very limited memory. It has a very limited memory. Now, like, what does this mean? DFA doesn't have the capacity. Let me use the word RAM as a practical example of this. DFA, the limited memory there is just like the RAM, in such that DFA does not have the capacity to keep to memory, like storing previous occurrences. Just like what had happened. Let's say, for an example, I have A, B, A, B, C. Now, if I have A, B, C, and I'm not telling DFA, okay, guy, could you just please help me in writing this thing in another form? DFA probably will tell you that, oh, I'm sorry, the only reason I can write this thing is because I'm able to store this one. And that is why with the memory of what I've stored, that's when I can be able to what? To formulate a different arrangement for this. But because of DFA doesn't have that, it has a limited memory. DFA cannot, it won't be able to do that. So the only one that can do that is NFA. NFA will be able to do that. So at some point, we test this thing I've just said now. I'm just trying to explain this. So at some point, we test it with some questions. You will see that DFA actually has a limited memory. So that's for that. Then let us now see the structure of DFA. The structure of DFA. Structure of DFA. So if we want to look at the structure of DFA, then we must try to consider five tuples. Is it tuples? Five tuples. There's out there. Five tuples of DFA. The five tuples of DFA, we have the what? The Q. And the next one we have the what? The sigma. The next one we have the Q naught, right? The next one we have the what? The F. And the last we have transition. Now I'm going to explain all these things. The first one here, Q, stands for what I call the set of what? All states. Is a set of all states. The sigma here, which is alphabet, simply means what? The input. It is all the input. Why the Q naught simply means the what? That is what? The first what? The state of, that's the first, we call it initial state or the starting state. Why the F means final or what? Or finished state. And the transition there means how input move from one state to another. That's what it means there. So let us see, let's put a meaning to all this so we do Q. The Q there says is a set of all states. So the next one is a sigma. Sigma is those inputs. And this input could be 0, it could be 1, it could be A, it could be B. So next one there is Q naught, which is what? Initial. Initial state, initial or starting state. And the next one is F, which is final or finish state. Why we round it up with the what? The transition. So the transition is so I'm going to explain this later with transition diagram. So these are the, so this one means transition from, let me just put something here. Transition from one state to another. So now let us do a diagram. So if we are doing a diagram, we want to do a diagram with four states. Please let's look up. So we have 1, 2, 3, 4. So we have, this is A, B, this is C, and this is D. So this D is our finite. The A happen to be our start state. Then we have transition. This is 1. We have our transition. That's from B to what? To A. 1 again. Okay. We have another transition here again. So this transition, this one is here from C to A and A to C. So this is 0 and this is what? 0. So another one here, another one here again. So we have this one, this is 0 and this one is 0. This one, another one here. Sorry, there's another one here, and lastly another one here. So this one is 1 and this is 1, and we have one here. Now this diagram, you are not actually meant to probably memorize how to draw this diagram, but you just have to understand how the diagram of DFA looks like, because whatever you are solving will probably look like this. It might not look fully, but it will have this kind of diagram in DFA. So I guess we are cool. So let us see how we want to use this diagram to analyze few things. Now, in this place, I was explaining something. I said transition from one state to another. This has not properly been explained. So we need to see how these guys, these states, how they move, how that they interact with each other and the rest. So from this place now, we have the start state or the initial state. So if I have input of 1, Frank, if I have input of 1, I move down to what? State B. Okay, so in state B, if I have input of what? 1 also, I move down to what? To state A. In state A, the input of 0 is what moves me to what? To the next state C. In state A, the input of 1 is what moves me to the next state B. In state B, the input of 0 moves me to D. In state D, the input of 0 moves me to what? To B. So it goes like that, and this is the finished state of all. This is it. So the finished state will always has a double circle just to indicate a difference. While the arrow, the state with an arrow pointing at that circle is the start state. I guess that is clear. Any question?
What determines what the input?
Let's finish up first. There are some things I still need to put down. So I have this now. All this, I guess you guys have written on this. Let's finish up first. So we want to use states now. You know, before we are using words. Let's use these states to explain this. So state of all, this is Q stand for set of all states. What are the states there? A, B, C, and what? And D. Right? Set of what? Inputs. What are the inputs there? 0 and 1. The start is what? A. The finish is what? D. And the transition. This transition, the best way of getting transition is using transition table. So if we try using transition table, I'm going to rub this off. Let me turn the camera. So using a transition table now, hold on. So we want to use a transition table to get this transition. Using the table, we want to use this diagram. So we have what here? 0, our input, and 1. 0 and 1 input. And what are the states there? We have A, we have B, C, and what? D. So let's look up. Now, if we have input of 1, sorry, 0 input, if 0 is entering A, 0, 0, input 0 enters A, it moves to what? It moves to C. If input 1 enter A, it moves to what? B. We'll go to B now. If input 0 enter B, it moves to what? It moves to D. What's your question? If input 1 moves to what? Enters what? B, it moves to what? To, is it A? Equal to A. And C, we have input of what? 0. It moves to what? To A. Next one, what? 1. It moves to what? It moves to D. D now, we have input of 0. It moves to B. And input of 1, it moves to C. So these are the how these things.
In the place of that C now, input of 1 moves to D. Okay.
Is it clear now? So this is how this is the transition function from one state to another. So this thing now, this is what we call transition table.
The question, sir.
Okay, your question.
Who determines the first state?
What determines the first state? You are the one. So you could probably use Q naught or A. It's your choice.
The initial state.
Initial state is this arrow.
Who determines it?
Of course, every question must have initial state.
Final state.
Yes, it must have initial state and it must have final state. Reason, yes, when initial state is where it will start. Your final state is what determines if your answer is correct. So there must be initial and final. That's why we have it here. So from the parameters, you could see I stated the final and I stated initial. So if it is not something important, it will not be part of it. Because in deterministic finite automata, you need your what? Final state in order to get your answer. Final state is needed. So, and it is what the input that arrives there, that's what determines what your answer looks like. So let's pick a question now. You will see how we are going to make use of this. Okay.
No, the way you wrote the A, B, C, D.
Okay.
It says when input A, when an input 1
Yes.
enters into A, it goes to B.
Mm.
And when an input 0 enters into A,
It goes to C.
What if it's the other way around? Like when an input 0 enters into A, it goes
Now,
to B.
each question, that's a very good question. Each question has what we call algorithm it follows. So in every question, they will tell you what is accepted in the algorithm and what is rejected. So you will look out for what is accepted and you look out for, okay, what if I have something that is not accepted? What happened? But you will dwell more, your answer will be what is accepted. You get it now? So that's what determines what becomes your final and where your answer will be drawn from. So let's pick this question now. You see how we do this. The question says, can I rub this? Now, this is a question that says set of all strings that begins with 0, design a DFA for this. Now, you see the reason why we need to have the understanding of computation. So, in that computation, we've been able to understand that set of strings that begin with 0, that is what? Infinite. You get that? Because it will always start with 0. like that. So you just do it at some point, you leave it there. So here now says design a DFA for this also. So let us see how we're going to do this. So we have our solution. Now set of all string that begins with 0. So we could say 0, and next one is what? 0, 1, 0, 1, what? 0, 1, 0, 0, 1, 1. So we could also say 0, 0, 0, 1, 0, 0, 1, 0, and 0, 1, 0, 0, 0, 1, 1, 0. So goes that way, and we stop it there.
Denoted as W.
This is denoted as this one now. This what you have here is called language L.
But the set is W.
The set now is strings.
W.
Yes, which is what? W. You get it now? So, and this was actually gotten from, I'm sorry I did not start with that. It was, this thing we are doing now is generated from alphabet 0, 1. So, let us see how we want to design DFA for this. Now, that's your question that says, how do I know what we did a DFA and we said 1 enter, it moves to the next state, 0 enter, it moves to the next state. How do I know what enters that will makes me what, or give me the permission to move to the next state? Look at that. There is an instruction there that says set of all string that begins with what? 0. See, that means we have to look out for set of all strings that begin with 0. So in doing that now, please let's pay attention. The first one now, 0, our start, A. What do we have? It says that what? Set of all strings that begins with what? With 0. So if I have 0 comes in, accepted, it moves to what? State what? B. From state A, 0 comes in, it moves to state what? B. From state B, you now ask yourself, since I've been able to have 1, 0 comes in, accepted. What then happen if 1 comes in? What then happen if I have 1, if 1 comes in? And you also ask yourself this question, where's my final state? This is my start state, and this is my what? This is the next state, the start state, the next state. Where is my final state? My final state will be this. Reason because I've been able to fulfill their instruction that says that set of strings that start with what? 0. Set of strings that start with 0. Now a string has one string as we have 0, set of strings that start with 0. This has moved in here. We have from moved in into A, we move to what? B. Now, what you need to do now is to ask yourself, what about, there's what we call self loop. Self loop. This self loop helps you to do what we call, instead a particular, if you have a particular input, instead that input will take us to next state, it will help us to remain in that same state. That means the input will go back to that state. So at this point now, what we need to do here is to do what we call a self loop. And a self loop there, since we have gotten to the final, from this A we have 0, we move to state B. Ask yourself, if I have another 0, and from this state B now, if I have input of 0 or input of 1, where will it go to? It can't go out, it can't move from here to another state. So what will happen is that we want it to remain in that state B because that's the final state. Because in this state, it says that is strings that start with what? 0. And we've already achieved that by saying A, input of 0 leads us to the next state, which is B. Now, at this B now, this is our final state now. But we have to do a self loop in case we in this state B, we now have another input of either 0 or 1. Therefore, since this B is the final state, if we have another input of 0 or 1, remain in that final, don't move out. So the question here again is that have we arrived at our final answer? No, this is not our final answer. Reason because I said earlier that we have to check out for what they asked us to check out for, and also check out for what they did not ask us to check out for. For acceptance and for non-acceptance. So now, in order to check, we have checked out for what? For 0. We have to check out for what? 1. To see if we now have input of 1, what happens? To have input of 1 here now, the best thing to do, how to solve this, is to, you have gotten to this state, just leave that aspect. Come here and put, if I have input of 1 from this start, where is it moving to? We have to move another one here, and this one now we move to what? C. This C is not a final state. We just have to indicate and tell them that from this start state, I have input of 1. It took me to next state, which is B, and I'm following your instruction. Input of 0, sorry. It took me to the next state, which is B, and I've gotten to the final state, accepted. Now, what happens if I have input of 1? Input of 1 cannot take me to the what? To the next state. What it will take me? It will take me to a state whereby it will become what we call it dead state. Dead state or trap state. Dead state or trap state is known as a state whereby we cannot move from that state to another state. Any input that we have inside this state cannot move from this state to another state. And again, that dead state is not also what? A final state. So it is just showing us that any input that is not what we are asking for, this is where it goes to. It remains there. So we have 1 has entered here. What about if from A here, input of 1, we move to what? To C. From this C now, if we have another self loop, from this C now we have input of 0 or input of 1. Is going to remain there. Like I said, it's what? A dead state. Any other input that enters that C state will trap there. It can't move from this state to another state because it's carrying what? What is carrying here? This C here, in the first place, what generated this next state is what is not accepted. So that's for this now, we've been able to draw a what? A DFA perfectly.
That B now. Why 0? When what generated it? What entered was 0.
Now it loops. Reason because it has to loop. Reason because at state B, we can still have another input. So anything, and don't forget that we've already arrived. Following the instruction that says start with 0 has made us arrive at final answer, final state. So at that final state, perhaps there is another input at that final state. We cannot move. We say something is final. We cannot move from this place now to move to another state. So therefore, whatever that any input that we have, whether 0 or 1, regardless of whether we are having 0, doesn't matter. The 0 is only obeyed at this point. What enters from A here moves to this place, gives us B. So whatever enters from this 0, at this B state, either 0 or 1, remains at that B state as the final state. So that is settled. Go to this one now. You now say, okay, I've tried for 0. What about 1? Though you didn't ask me to follow 1, but let me show you what happens if 1 is imputed. If 1 is imputed, we have from this state A, it takes us to state C. And this state C, since we are not following, 1 is not what is accepted, it moves to what? a trap state or a dead state. Any input again that we have here, either 1 or 0, will remain there because this one already is a dead state. It's not what is accepted for this question. So in this case now, let us come and test.
Can you define that dead state again?
Dead state is a state whereby we cannot further have any what? We cannot further have a next state. They cannot be. Yes, it did not meet up with the first condition. It didn't meet up with the first condition.
So in that state, the loop will terminate. Just
The loop, any looping, any input that enters in that C, the C will still remain there because it's already dead. So we can test. Let's say, check. Example now. We want to check if 101, if it is accepted or not. So in checking if 101 is accepted, how do we do this? We have the first one here that says if 1 enters, it says 0 what? This one say 1, right? If we have 1 enters, what becomes of that? If 1 enters, it goes to what? It goes to what? To C. 1 enters, it goes to C. Or probably, no, A, sorry. From A here, we have 1. You move to what? State C. From C here, we have another what? 0. This 0 here will become what? Self loop. It still remains in state C. The next one is what? 1. 1. Self loop. It still remains what? State what? State C. Now, how to know if you are correct? If this 101 is accepted or rejected, you now check A, C, C, C. Have we arrived at the final state? No. B is the final state. That means this is not accepted. So it must arrive at the final state. That's why I said in DFA, the input, our input determines whether we are moving to the next state or not. And that input also helps us to know when we arrive at the final state. And that final state will determine whether a particular string is accepted or rejected. So whatever string we are testing, we must make sure that that string gets to the final state. So let's try another one. If we have 0, 1, 0, 1, we have what? What do we have here? We have A, start, 0 enters. We move to what? The next one that enters is what? This one moves to B. We have another one, input of what? 1. This 1 enters. It still remains where? B. That's final, right? This B now, we check. Is B final state here? B is final. That says that 0, 1 is accepted. So we test another one. We could just say, let's say 001. Just put any number of your choice and test it. That starts with 0. So from here now, we can see that any number that does not start with 0 is not accepted at all. So if we try this one now, we have 0, A, 0 accepted. We move to what? To B. We have another 0. It moves to what? That 0 now, still self loop to B. We have 1. That 1 self loop to what? To B. So this 001 is accepted. So that's how this question solved itself. I guess this is clear. Any other question for David? So if we solve another question, it's going to be in another video. This video is, is already long enough. Let me stop it.